Hello students. Today we're going to continue looking at modeling with functions, and we're going to be focusing on different geometric situations. The goal here is twofold. First, of course, one of our goals is to get more comfortable using functions to model real situations. But another goal is to get more practice and comfortability with certain shapes and relationships between shapes, so that when you get to calculus, you are better prepared to deal with the different situations you may run into there. So let's start with our first problem. A 5-foot tall woman is standing near a street lamp that is 12 feet tall. Find a function that models the length L of her shadow in terms of her distance d from the base of the lamp. Let's draw a diagram. Here is the lamp, and we know that it is 12 feet tall. She is standing some distance away. This distance will be d, and we know that the lamp casts a shadow. This over here is the shadow, and it has length L. And this is a right triangle because we're assuming that the lamp is standing tall just like any street lamp should be. And so what we want to do is we want to find the relationship between D and L and write that length L as a function of D. Also, I forgot to label that she is 5 feet tall. Now, the relationship that is going to occur here is going to be that of similar triangles. This large triangle is similar to the smaller triangle that the woman and her shadow make. And when we have similar triangles, the corresponding sides are proportional in length. So if we look at the heights of these triangles, the ratio of those, 12 to 5, that's going to be proportional to the ratio of the bases. The larger triangle's base is D plus L, and the smaller triangle's base is just L. So we can use similar triangles here to express a relationship between these quantities. And what we want is we want a function that models the length of her shadow in terms of the distance. So we want to solve this equation for L in terms of D. Now here we have an equation with fractions in it, and to get rid of the fractions, to make it a simpler relationship, we need to multiply by the LCD. In this case, the LCD is 5L. So if we multiply both sides by 5L, we're going to be able to get rid of those fractions, which will make things easier to deal with. Now on the left-hand side, the 5's are going to end up canceling, and that gives us L times 12, which is 12L. On the right-hand side, the L's cancel, and that gives us D plus L times 5, which we can multiply by distributing the 5. So we get 12L equals 5D plus 5L. And we want to solve for L in terms of D, so we need to get all the L terms on the same side. We can subtract 5L from both sides to accomplish this. This is going to end up giving us 7L equals 5D. And then to get L alone, we divide both sides by 7, and this gives us L equals 5/7 times D. And so this is how we can write L as a function of D. The length of the shadow is going to be 5/7 times the distance that the woman stands away from the lamp post. Now, why would we ever need to know this? Students often ask, and one answer is in video game design. If you are going to design a video game that involves 2 dimensions or 3 dimensions, a representation of the world, and you have lights anywhere, you have to deal with shadows, and the lighting design requires knowledge of how similar triangles work and also functions so that the length of the shadow can end up being calculated. It's interesting that so many students are super into video games and they don't realize how much algebra and geometry goes into designing and creating and coding those games. So if you want to get really good at video game design, you've got to have some knowledge of algebra and geometry.